I can see yes. All right, all right. So I'm sure everybody can hear me loud and clear. If you have any issues with your audio, quickly fix it. And then let's get to know what you have any problem with. So I'm going to be introducing the trainers, and we have three of them. The first person will be speaking on OWASP security framework, and by name is Glenn, and he's going to be spending an hour 45 minutes for the real part of the session, while the 15 minutes will be dedicated to questions and answers. So I'll just implore us to listen carefully, listen very well, take notes of questions we might need to ask towards the end of the class. And if you want us to interject him during the course of the session, he will tell us so that we can ask our question. My name is Ayokunle Olani. I'm going to be your host for today. And during the course of the session, we will introduce the second speaker and the third speaker. Each of them has 1 hour each. So I implore us to utilize this opportunity because I'm sure they have great content to present. The floor to you, Glenn.
Thank you very much for the introduction. So yeah, my name is Glenn ten Kate. I'm actually doing now more than 15 years professionally security. Yeah, and I'm here to help and explain, my knowledge and the lessons learned so far in these 15 years. And of course, I'm here to present the security knowledge framework to also give you the tooling and make it very actionable to also, be in control of your security, how to properly develop secure applications, and also, really to train yourself, getting more skills and more awareness about security. So first, we're going to talk a bit about the secure software development lifecycle. So how does it look like? How should it look like? And then do a sort of gap analysis. And after that, we do a deep dive into the security knowledge framework and how this framework that I built with my brother, Ricardo, how that can help you in your day-to-day operations, but also in getting more awareness, more hands-on experience in terms of finding vulnerabilities, exploiting them, but also fixing them. So that is for the hour that I have planned for you guys today. Indeed, if you have any questions, please put them in the chat and note them down. Then we take the last 15 minutes to deep dive into your questions or concerns. All right, so let's get it starting. And we start actually already with a nice cases. Actually, the challenge of SEC DevOps. Because as you know, we used to program, and when we did program and development, we used to come from a waterfall approach where you, worked quite a long time on a deliverable, and after like a couple of months, you would deliver your final product. But now, of course, when we talk about DevOps and agile development, you work in very small sprints, and you basically release features per sprint, right? So you have small iterations of releases that you do. And of course, here we have a challenge because how does security fit in this very fast pace of deployment and releasing? So we have here a challenge, and we will try to overcome this challenge with like tooling and processes, and that's all good. But still, security leaves a big challenge there, like a big question mark, how to do it properly. So in the first beginning, I want, like I said, explain a bit about the software development lifecycle, or in this case, the secure software development lifecycle, and which of the minimal steps you would normally have when you're developing code and a product. So it all starts with, of course, with everything you do, your functional requirements. But with functional requirements, you also have security requirements, right? And if you don't have any security requirements, well, that would be already the big issue, number one, if you don't use that, right? Because then you will develop best effort code. And in the end, there are tons of vulnerabilities in there because you as a developer were simply not aware of all the possible attack vectors. So using security requirements and couple them to the features you're building and releasing is super important. That is step number one. You have different type of standards for that. You have the ASVS, that is an OWASP project. It's the Application Security Verification Standard. You also have the mobile version of it. So if you're also developing mobile applications, you can use the MASVS for that. And of course, like NIST and all the other big organizations and standard bodies, they also have lists for developers as security requirements. Then we have, of course, like test automation, for example, code quality. And you need to be able to do test automation. If you don't have your end-to-end process, your release, your functional testing automated, then of course you also cannot deliver this high pace of releasing, right? These features in those sprint-based. So test automation and especially code quality is also key important when we talk about secure development, because dead-end code or over complex code or repudiated code, that all has also impact on security, right? Because when you, for example, going to do a code review and audit, and your time is basically reviewing dead-end code, well, that's a waste of time, right? That you probably would have wanted to spend, for example, in very complex code. And if the code is overcomplicated, that means it's hard to read, so business logic vulnerabilities are likely to occur there. So having test automation, and not only about code quality, but also end-to-end testing, unit testing, all those different elements contribute to the security of your application, right? And the quality of your application. Then, of course, in a software development lifecycle, you would also want to have security test automation. And this is specifically for security, right? So you have the static analyzing tooling that looks from the source code of the application and find vulnerabilities. Then you have the dynamic application security testing tooling that is checking the application in a running state. And of course, you now have since a while like a new kid on the block. It's called EAST. So that's the interactive security testing. And basically what that is a combination of SAST and DOS tooling. So this is actually having more context, more information, find better vulnerabilities, and less false positives. So security test automation is something you definitely want to have as a security quality gate in your pipeline, right? In your secure software development lifecycle. And of course, we still have manual verification, right? You need to do peer reviews, you need to do code audits, you need to do penetration testing on the releases that you do. So if we deep dive a bit into a couple of the SaaS tooling, so you have the Fortify, the check marks that really look from the source code of view. You have the OWASP dependency checker that also looks at what type of libraries you're including in your project. Because, as you know, the libraries you need also to update, right? It's very common that you use a library, and if you use a too old version of it, it turns out it has already vulnerabilities in there. So that means by default, if you use old libraries, your application is already insecure. So another great OWASP project, the dependency checker, helps you with that. And of course, you have also different tooling, right? But the idea is you have a list of static tooling that you will use. Then a couple of examples of dynamic security tooling, like the Akunetics, AppSpider, Burp. And of course, from OWASP, we have the OWASP ZAP project. And this is actually a tool that will dynamically scan your application and test for vulnerabilities. So again, you have good open source projects, from OWASP that can help you in the SAST and DOS quality gates and improve your security there to embed those into your pipeline. And like I said, now you also have EAST, the interactive application security testing. I'm not aware of any open source projects yet because, like I said, it's a bit of a new thing. But here you have a couple of commercial vendors that are now offering this service, this approach of doing security testing in an automated way. Um, Ideally, when we talk about security testing, right, and your pipeline, you actually want to have something that is reusable. So here we have, for example, Jenkins as our platform, our working platform. And what we actually want to achieve is on the moment somebody makes a pull request to the repository, then Jenkins, your build platform, in this case Jenkins, would notice that and start kicking off the different quality gates you have, for your project, like end-to-end testing, unit testing, dynamic security testing. So here you see an example of ZAP being used. And ideally, what you want is actually to have everything running in Docker. Because the cool thing is, if you do that and you build all your tooling and your quality gates inside Docker containers, then if you later change the build platform, so not using Jenkins, but Azure DevOps or Travis or GitLab or whatever, you can still reuse all your tooling that you build in Docker, right? Um, Before, what people would do is making all those things and tools available in Jenkins, and on the moment they then swap out Jenkins for a new build platform, yeah, they had to rebuild everything. So really, the idea is to have everything in Docker containers. So again, you have your repo, there's a code fix or a code push, Jenkins sees it, launch all the different quality gates. For example, for security, it will run the Docker container of ZAP, and ZAP will scan your application, and when it's done, it will kill the Docker instance and it's done, right? Then you also need to do something with the findings. And for that, we have another great OWASP project. It's called Defect Dojo. And what it can do is basically the result of your quality, security tooling, like your SOST and DOS tooling. It can push those findings to Defect Dojo. And Defect Dojo is basically a vulnerability management system. So here you can manage all the findings that came out of all the tooling. And then optional, you can, validate them, shoot them into Jira or to a Slack channel, something like that. And you have the findings at the developer. So now my question is actually to you guys, and please paste it in the chat. So if you use those static and dynamic security tooling, what do you think is the coverage? So how much of the vulnerabilities would we cover using the SAST and DOS type of tooling? What is your guess there? And please throw it in the chat. Okay, somebody says 30%. More or less? So I will tell you, it is actually around really maximum 20% of the vulnerabilities you will cover. And not only that, you also have to deal with false positives, right? And what are false positives? That's basically the tool telling you, like, hey, I have a finding, but when you research about the finding, the finding from the tool, it turns out that actually it wasn't a real finding. It was a false positive. So because of lack of context, or the tool actually flagged something as a vulnerability, but when you research it, it turns out it's not. So that's what we call a false positive. So also you have to deal with that. So what another OWASP project did, the OWASP benchmark project, actually created a sort of tool and source code to verify the quality of the different SOS, DOS, and EOS tooling. And basically, they measure how many false positives did the tool generate and how many true positives, so real findings, did it find. So ideally, you want to be here in the left corner because it found all 100%, or between this, it found all these real vulnerabilities, and it didn't flag any negative, so false positives, right? So ideally, you want to be in the left corner. Yeah, I see some questions. Let me just jump into it right away. So yeah, unfortunately, you only will know what a false positive is by really researching it. So unfortunately, if you have many false positives being reported by the tool, yeah, that means that you will have to do a lot of manual verification to see and verify, yeah, that it is a true positive or a false positive. Because from the tool, we actually don't know, because the tool says, hey, all these things are a vulnerability, go fix. But then when you research, you find that some of them will be a false positive because of lack of context, yeah, that tool had about the application. So it's only, you can only find out by really deep diving and researching. Um, so ideally, the tools need to be in the left corner, right? And you see, if it's over here, it's basically everything that's vulnerable. In the middle, it's like random. And here it's also bad because, yeah, you have low amount of false positives, but also the tool doesn't find a lot of things, right? So there's a lot of issues here. So if you then look at real life example data, how the tooling are scoring. So here you have an overview of commercial tooling and open source tooling. You see that it's very spread, right? So a lot of the tools are actually in this corner, so it will not find a lot. Right here we have random guessing. So, and this is like the commercial average, 26%. But there's a big but for that as well, because the problem is that this is from what is possible to find. So if I tell you that 50% of all the vulnerabilities is related to business logic vulnerabilities, and security tools like SOS, DOS, EOST, there is no security tool that can assess business logic, right? This is something that you have to do with threat modeling, with proper design of the application, um, with manual verification. But 50% of all the vulnerabilities are related to business logic. So everything we have here, the score of 26%, you should actually cut it through half, right? Because it says here 100%, but it's 100% of 50%. You get my point? So if we take the best one over here, 32%, basically it will say it will find 15% of all possible vulnerabilities, because the other 50% are business logic vulnerabilities and they cannot find those, right? So it is good to have security tooling. It's good to use it, right? The SOS and DOS tooling, but you just need to be aware that there is still a gap. And that gap we need to tackle, we need to solve, right? That is the whole challenge as well of the whole SEC DevOps, right? Where we started the presentation with. Now with EOST, it's a bit better. So because it's a combination of SOS and DOS, so it will find like probably between like 30–40% of all the vulnerabilities. But again, there's a huge gap there, right? So I would say the EOS seems like a better approach because it has more context, because it can correlate the dynamic and the static approach together, and because it has more context this way, it will also produce less false positives, right? So that's why EOS is actually quite interesting nowadays, and people are really doing this type of approach in their security quality testing. I also told you that we actually need also, when we have findings, we need to manage them, right? Because there can still be false positives in there. And you don't want to go over every time your security tool has run through the same findings that you already marked as a false positive. So here we have the defect dojo screen. So that is the OWASP project, where we also included the OWASP dependency check scan. And when this dependency check scan has run, then the report, the findings are pushed into this defect dojo. And as you can see, the dependency check scan has found 3 vulnerabilities. And now in defect dojo, we can actually view the findings. So what is the issue? We can also mark them here as false positive. So the good thing about that is that the next time this tool is run in your pipeline, in your secure development lifecycle, this false positive will not pop up anymore, right? So you do only the first time the validation, and after that, you mark the issues as true positive or false positive. And if you mark them as false positive, the next time the tool is run, it will not display those findings anymore, right? So that helps and makes you way more efficient when you release quickly and have many releases actually, right? Because it only will give you the delta between what is new found, and the things you marked as false positive. So a tool like Defect Dojo can really help. And you need it, right, to do that vulnerability management. The cool thing about Defect Dojo is it also has like 35 different adapters for all different type of tools. So the OWASP Zap Scan, the dependency checker, Sneak, Fortify, all those tools I just mentioned, they have an adapter for it. So if you then push that report from that security tool to Defect Dojo, you will have all your vulnerabilities nice here, visible, and you can manage them and also flag vulnerabilities as false positive, so they don't come back all the time. So a must-have in your security development lifecycle and in your pipeline. Well, like I said, we still have a huge gap, right? Because in an ideal situation, we can get around 30% of the vulnerabilities and detect them using different type of automated security tooling. But we still have a huge gap of like 70%. So what do we need to do with that 70% gap? How can we be really effective? So we can really be effective by the developers. The developers who are basically Neo. I hope you guys all watched The Matrix. If not, you should leave this session, download or watch The Matrix first, because it's essential that you do. But you guys are basically like Neo, right? You are awesome. You are the one. That is where, you know, the true effectiveness is. The developers, training them, giving them the right set of awareness. And, you know, what we see a lot is with developers that there are many coding mistakes and they're quite, we say it like the same stuff repeating, right? Like deja vus. It is always like the cross-site scriptings, the SQL injections, all that good stuff. And it is not necessary, right? It is just awareness that wasn't there with the developer. So that's why we still have SQL injections and cross-site scriptings. But actually, it is not rocket science to solve. You just need to have the design pattern, the awareness, and you're good to go. And as developers are like Neos, they have like awesome potential, right? They can dodge even bullets like Neo. And now we see that these developers are actually barely hanging on. They're trying to do their job as best as they can, but with the limited security awareness to how to implement properly the features and functionality in a secure way, they're really like trying to dodge bullets. And guess what? They are Neo. They don't have to dodge bullets, right? Because Neo is the one. He can just stop the bullets. So the good thing is there's always options, right? There's the option to follow the rabbit. And in this case, the rabbit is actually the security knowledge framework. So this is a framework, a project that my brother and I started like 6.5 years ago. And it's basically there to help and guide developers in secure programming. And the idea is to really, have like a secure design instead of trying later to securing your design afterwards, right? because that's nearly impossible. And it's really about security awareness, informs you about threats, gives you right requirements and all the knowledge and information you need to actually build secure applications by design. And like I said, what is key important here is really setting up the right security requirements, right? Because that's the first step in doing security right. And I mentioned it before, you have the ASVS checklist. You have the mobile ASVS checklist. And basically, they have different levels of stepping in. So you have the opportunistic, the level 2, and the level 3 items. So if you're building very critical applications, you will implement 1, 2, and 3, all the requirements. If you're building a normal-ish website, you use the requirements for level 1 and 2, okay? And it gives you already a good idea and prioritization of the requirements that you should implement. Yeah, and of course, the other thing, why is that so important, is that in the security knowledge framework, we actually also use the ASVS, right? It's a very important part of the SKF. And like I said, the whole idea is with the SKF to make threats visible up front so you can properly, securely design from the start your application to be secure, so that these evil hackers and threats, cannot really do any harm in your application. But of course, it's also about taking responsibilities, making a choice. Because if you're new to secure development, you need to learn certain new things. So that means that the way you programmed for years, you will probably need to learn new design patterns, right? The proper design patterns to actually mitigate vulnerabilities. But yeah, let's have a look at the security knowledge framework, and I will guide you a bit through it to see how you can utilize that in your day-to-day work. So we have here the demo of the security knowledge framework. It's actually running on my Raspberry Pi Kubernetes cluster downstairs. So sometimes it's not working. Today it looks like it's working, so that's good. You can log in, but sometimes it doesn't work. Just use the skip login. Then you will log in as an anonymous user. And this is basically the landing page of SKF. So SKF, the most important thing is that it has like different components. We have code examples that gives you in different languages examples of functionality and how to approach that in a secure way, like a file upload or setting headers or input validation, stuff like that. Then we have checklists like the ASVS, but let's say you have your own checklist. You could actually also extend SKF if you log in as an administrator, and you can put in your own secure coding checklist or your own secure Docker checklist or your own internal checklist. So it's not only about the ASVS, but you can actually also put your own checklist in there. Then we have knowledge base items, and knowledge base items basically will give you more information about certain vulnerabilities or certain IT security jargon that will explain you what is actually the issue there and also the approach. And then, of course, we have the security knowledge framework labs. And the labs are quite interesting because there we have from very basic vulnerabilities like cross-site scripting, SQL injection, to very advanced vulnerabilities like mass parameter assignment vulnerabilities, race conditions, right to left injections, all that cool stuff. And here you can actually practice your verification skills. So these are tiny lab applications that you then need to exploit a certain vulnerability or functionality. And then, of course, we have the other thing, and it's the managing of projects. But I will keep that one for last. So again, you have code examples and many different code examples for different languages and functionality. So if we would go, for example, and see like, okay, an SQL query. So how would that piece of code look like in ASP, right? So here we try really to explain the context. Why are we doing something? What is the meaning of this? How would you want to do it? Well, here you see that we use parameterized query bindings. And why do we do that? Because this is a way how to prevent an SQL injection, right? Using parameterized queries and bind them. Let's maybe pick another one, like the directory path traversal. So when you're using file names and all that good stuff, you have like path traversal problems. And like an attacker can read files locally from the server that your application and you as a developer actually did not intend it, right, to do that. So here, like I said, you have a lot of code examples that you can look at and get inspiration on how to approach that, right? So it gives you detailed advice and knowledge. Then we have checklist, the web application checklist and the mobile application checklist. These are by default populated when you download SKF. So for web and mobile, you already have this checklist. So here you can see the different categories of the checklist. So let's say we go to the category for architecture, design, and threat modeling. And here you see all the requirements that are needed when we are talking and thinking about the architecture, design, and threat modeling. So like I said, ideally, in a critical application, you actually need to implement all these different requirements. And some requirements are really layered security approach, because security is layer on top of layer on top of layer. And others are like really edge protection, right? Like I said, the SQL. So if we go, for example, to the input handling, let me see where it is. Probably it's like this one. And over here, you see it's all about input and stuff like that. So here we have a requirement that says verify that data selection or database queries, for example, SQL, HQL, ORM, NoSQL, they all use parameterized queries. Yeah. So some of the requirements, if you don't do them, right, like this one, you have SQL injection. Yeah, and that can be a direct impact for your application, right? Because if you don't have SQL protection, somebody can just do SQL injection, dump the database, dump the users, dump sensitive information, and yeah, your application is breached. So some have high impact and direct impact, and other requirements are really layer on layer on layer, right? Layered based security. So here are the checklists. And again, if you log in as an administrator, then you can also add your own checklist, add your own topics, add your own security requirements. Then we have the knowledge base. And the knowledge base is basically like 500 plus knowledge base examples about certain problems, right? For example, in J2EE, like weak access permission for the EGB methods. So you can click it, you get a description of, hey, what is actually the problem here and why should we care? And then the mitigation, what should you do to make sure that you don't have this issue, right? So it gives you explanation and a mitigation. And also for like .NET, missing custom error page. Okay, so what is that? To prevent attackers from mining information in the framework's bulletin response. So what do you need to do? Well, you can do 3 of these steps: system configuration, architecture and design, and implementation, right? So here you can find a lot of good information about all different type of design patterns, approaches, or specific vulnerabilities that can occur. And the cool thing is, we also have like a machine learning chatbot in SKF over here. So if you have SKF running, you can actually deploy a chat bot, And you can ask this person, this chatbot, for different things, like give me code for prevention of XLS. And it will give back the code snippet from SKF back in the chat. You can also ask like questions, hey, how do I solve XSS in Java? So it will give back the solution part, the mitigation part of a security knowledge base item, right? So it will give back this part, the mitigation part. If you would ask like, what is something? Yeah, so here, what is HSTS? It will give back the description part of that knowledge base item. If you would ask how to solve it, it will give back the mitigation, the solution part of that knowledge base item. So all the knowledge that is in here, of course, you can search in here, you know, in SKF, you can search it and get that information, you know, like here, something about SQL injection. Yeah, you can search and get it, but you could also just use a chatbot, deploy it and ask questions because it has a machine learning chatbot as well, the SKF application. So those are knowledge base items. Then we also have the labs, like I said before. So when we go to labs, we see that we have the SKF labs and we have Juice Shop. Juice Shop is another great OWASP project. And it also has like a lot of vulnerabilities you can practice with. So what you can do is, let's say you have in your application a path reversal, right? The one we just discussed, the local file inclusion. What you can do is just press the start button, and now SKF is going to deploy a vulnerable application with a path reversal vulnerability in there. So that means you can actually then go to that URL that is going to be given to you, and legally, in a safe way, you can practice there your skills, yeah, to train yourself in finding those type of vulnerabilities. So if I now open, yeah, that URL, or a different one, yes, this one, I open now the URL and you see we have now a lab here. So in this lab, we can now start doing the local file inclusion path reversal. So this is, of course, a very easy one. It's one of the beginners, but let me show you how it would work. So you have the source. You see there's one type of application, one function. It's like this drop-down menu. And when I click different menu items, it will show me different text. So what we will do in this challenge, we inspect this form. When we inspect it, we see that the values are actually direct links to text files. So let's change this value over here, right? Change it to A to say password A. So instead of getting that file, let's get the passwd file. So the intro option is now selecting that as a value. And if we submit it, you will now see, instead of the file that was configured in that menu item, we now have a file from the server being loaded by the application and presented to us, right? This is a local file inclusion, a path reversal vulnerability. The other cool thing is that if you're not that familiar or you need like help, there are also write-ups. So you can click here on the write-up, and here is like, hey, how to run it locally, but we run it from the SKF instance itself. And here you have like the reconnaissance phase. So it's actually explaining you step by step. What do we see? How does it work? Here's the piece of code. You see what the problem is? We have the form that we're getting, the file name. And what are we doing with the file name? We are just putting it directly in an open function without any validation, escaping, or whatever. So it means that the attacker controls everything that goes in this function. Then we have the exploitation step that, again, explains step by step how you can do the exploitation, right? So, and again, for all the labs, like the interesting labs, we have all nice write-ups for that. So it's a really cool place to, you know, learn about offensive security. and train yourself in how to verify also vulnerabilities in your own application. In the near future, we're also going to release an update for the labs where you have an editor where you can also see the code. And after you exploited the code, you can also start fixing it. So in like 6-7 weeks, we will release a new version, and it will also have this editor inside the security knowledge framework. So the last thing, as you see, I mean, it has a lot of information, right? It has like a central place for you to have your requirements, your checklist, your knowledge-based items, your code examples. You can practice labs, right? And training your verification skills. But the other important thing is how to use SKF in your day-to-day operations. Because the checklist actually are also used in the managed projects. So here, what you can do is basically generate your requirements for the feature you're building. Because the problem is that most of the checklists have like a lot of requirements, right? Like the ASVS has like 290 different security requirements. And it's really hard for when you're building something to go over those 290 requirements to see, okay, which one is applicable for what I'm now building. So in SKF, what we did, we made this expert system where you basically can select what type of application you're building. So let's say web. You can say what type of maturity level are you want to have. So let's say we're going to build a very critical application or a very simple application. So you select the different levels of requirements you want. And here you select the category. So let's say we're building like a login mechanism. Or no, let's do it simpler. We are building an input field that can perform searches on our application. So which of the things do we then need? Well, actually this one. We need to have validation, sanitation, and encoding verification requirements. Because we have a search function that we want to implement on the site. So when we select that, it will ask a couple of questions. And this is the expert system. So are you going to do something with SQL? Yes, we are, because we're going to search in the database, right? We're not getting local files. We are going to output user-supplied information to the browser, so we say yes. Let's see, input validation requirements, yes, because we are going to use HTTP post request and stuff like that. Are we going to do OS commands? No. LDAP? No. XML export? No. And we're also not going to deserialize? No. So we say now next. We say it's a new feature. It's actually for sprint, I don't know, number 3. And we're going to make a search function. Yeah. Now we do next and submit. So what SKF is now doing, it's correlating from those 290 security requirements in ASVS and picks only the requirements that are actually needed for you to do. So here we see our sprint number 3, search functionality, view. And these are now the 11 security requirements that you need to be aware of before building this search functionality, right? So you need to think of defenses against request parameters, right? You need to verify the framework protects against mass parameter assignment attacks. You need to verify all inputs using input validation. You need to do parameterized queries because you're going to use SQL queries. So here you have step by step the right requirements using the expert system of SKF. So it will, for you, based on the questions, select from the 290 requirements only the ones that are applicable for your feature that you're going to develop. So normally, you take these requirements, you export them, and you add them to your sprint as security requirements to build that search functionality, right? And you can also click here. Then you have a bit more extra information, like references to the cheat sheets about input validation and mass assignment, or to the Mitre website, or again, explanation about how you can tackle or approach this security requirement. So a lot of people use SKF, especially because of the managed projects and getting the right security requirements for the features they're building. But SKF is way more than that, right? It has code examples with snippets, with different information, different examples of code examples on how to approach things. You have the checklist, right? Where you can see the different requirements in the different categories of the checklist. You have the knowledge base items, and you have the labs where you can practice your security skills and verification skills. So that is on SKF. So like I said, SKF, super awesome. And why do we want to do this? Why do we want to do proper security requirements, creating awareness? Because as you see, if we do it properly in the beginning of the phase, in the requirements phase, the cost of fixing and preventing vulnerabilities is really low. It is an effort. It's not zero. It costs money, but it's way less than, hey, we have a vulnerability that we found in production. Let's now fix it. You see, it costs 30 times more than that. And the last slide. So how much would it cost? Here you see it would cost like around $100 per requirement in the requirement phase. If your Q&A testing phase it's found, it will cost around $1,500. And if it's found in production, it would cost a big organization $10K to fix that vulnerability. And this is not the impact, right, of the vulnerability. You can have an SQL injection, yeah, that is also a bug. To fix it, it will cost $10K, right, in production. But if somebody exploits it, then the impact of that vulnerability is even higher. For some companies, it can be the end of the company, right? If you have a very privacy sensitive organization that deals with sensitive information, if in that application is an SQL injection, yeah, the cost of fixing it will be $10K. But basically, if the whole database has been stolen by a hacker, then actually the business is going to, yeah, to stop, right? So the impact is millions, right, of a vulnerability. This is only the cost of a bug to solve it, to fix it, not the cost of the impact. So you could actually increment this number you see here with also the cost of the impact of a vulnerability and a bug. So that's why it's important to do things properly by design, security by design, having the right requirement and awareness to solve it in the beginning of the phase, right? Before you start programming. And like I said, Neo doesn't have to dodge bullets. Neo is Neo, he can stop bullets, right? And that's the developer, Neo. They have the knowledge and experience. They can do this. We just need to help them with the right information and the right training so they are ready for battle against those hackers and evil people. I would say we have some time left for questions. Who has some questions for me?
Wow. Glenn, you arrested me. I won't lie about it. The KSF framework you showed us just made me sad, in the sense that I've always seen it from the surface. I never knew it was this deep. So you made me sad. So I have a lot of things to cover up, and to be able to meet up with the game. It's been a very, very interesting class. I won't lie about that. And I'm sure a whole lot of other persons must have learned a lot of things from this, right from ASVS up to the cost of fixing security issues in your applications. It's been an interesting session with you. So this is question time. If anybody has any question, I think it is the best time for us to ask any sort of questions as regards what Glenn has taught us today. Any question from anybody at all? Any question whatsoever as regards the KSF, the IAS, the SAS, the DAST, and a whole lot of things. Yeah, so but while we're waiting for other people's questions, yeah, Glenn, you mean you guys developed it and OWASP adopted it?
Well, it is actually like this. So, like 6.5 years ago, we built the security knowledge framework because I was working at a company where they released like 50 times a week. And they told me like, okay, Glenn, how do you gonna tackle security? So then I thought, okay, let's build a better security tool, like a better DOS or a better SOS tool. Um, but we found out that those tools have really a lot of context that they're lacking. So that's why you have a lot of false positives, and that is not helping, right? So then I thought, what is then a better approach? So I brainstormed with my brother, and actually we thought, well, we missed the whole point. The root cause is the developers. They are not aware of all these different problems that can arrive when you build certain functionality. So then the idea is to train and make the developers aware. Was born that idea, and also to have like this expert system, because we thought if we could ask the developer a couple of questions, then we would have context, and with that context we could give them proper advice on what to do and what not. And so we built the whole security knowledge framework, the proof of concept, and it worked really well in that company I was working. It was already an open source project. And then we had a training there from Jim Manico, one of the OWASP old board members, and a very good guy in the OWASP community. And he did a training there, and I showed him the project and that it's open source and what he thought of it. And he said like, "Whoa, dude, this is amazing." And hey, I see you use your own checklist, but I together with a group, we built the ASVS. You should actually use the ASVS in there. So then I did some research about OWASP and ASVS, and then I saw like, we align in our approaches and our vision and strategy. We want to help the open source community and the world to do proper security, and security is really hard. So our mission, was the same, and from that moment we decided to join the OWASP community and put SKF also in there.
Oh, that's great. That's interesting. And since it's an open project, I think anybody who is willing to contribute, like myself, would really like to be part of something as huge as this, even if it's a few lines of codes that I might just have to write. I would really like to be a part of it. I'm sure a couple of other persons here will also like to be a part of it. Is there any how do we go about that? Or it is closed, or let me just get to know about it.
So how you can contribute, I would say the best is join like our Gitter or Slack channel, because we have quite a community there. And normally people, they just contact me there and ask like, hey, I'm good at I don't know, Python programming, or I'm good at building labs, or I'm good at reviewing knowledge base items or stuff like that, right? Because everybody has their own skill set and what they can bring. And with them together, we will see then what is, for that person and for us, the best added value in terms of help. So it's always a discussion normally, right? Because we really want to help and guide them and also mentor them to deliver and help us, right? So we are very open to feedback and help. Just shoot me a message on Gitter or on Slack, and I'm happy to set up a meeting and explain and see how we can mentor and contribute together.
All right. That's interesting. Thank you very much for that. So please, any other question from any of us? For those who have been part of the class from the beginning to this very point, any question or questions? Yeah, because I know we've learned a lot of things from what he has discussed with us today.
Yeah, it is indeed a lot of information. So it's good that you recorded the session. Then later people can also revert a bit back. Um, but yeah, I really wanted to give like the total picture, you know, like the lessons learned, the gaps, because a lot of people think like, okay, let's buy this product and now we don't have to do security anymore. Like this black box tool, right? This silver bullet. Let's buy it and we're good. But yeah, as you see, a lot of companies did that, and yes, it helps and it's good to do. Um, but yeah, it is you know, like I said, still has gaps, right? We still do need to do more. And the lessons learned is also if you release like 40, 50 times a week, yeah, then you need to have like a serious infrastructure of SOS and DOS tooling, right? And with serious, I mean, you need to spend a lot of money in it because normally a SOS or DOS tool takes quite a long of time to run. In some cases, it can run even up to like 10 or 24 hours. So how are you going to do that if your security is a quality gate? You want to release like 50 times a week, but one of the scan is already running for, let's say, 10 hours. So how do you do that? It's nearly impossible then, right? It's like security becomes a blocking issue. So also to overcome all those things, basically what we try to show is that, yeah, you need to have security minded people who have security requirements, that they have a place where they can get the right requirements, where they get the awareness, where they can get the training and the knowledge. Well, we think, and what we see in using SKF in all the organizations that we worked in the past 6 years, that this approach really solves yeah, the SEC DevOps challenge. We really need to train, make the developers aware, use security requirements, and yeah, we made it all actionable and doable by using the security knowledge framework. And everything I just showed you in SKF, if you run it locally, you download it, it's all there. The checklist, the knowledge base, the code examples, the labs, everything is there to use and yeah, get
Okay.
you started.
Okay. That's great. Thank you very much. Sorry, do we have access to this presentation? I mean, to this slide?
Uh, yeah, I think so. I also sent the PDF of it. So, but I will also put this in the chat for people who want to join now. And I think I also send the PDF to the host, so he can share it as well.
Okay. All right. Someone asked a question. It says, I was off for a while, but I want to know if it does scan after production.
Yeah, I think he missed a bit because actually SKF itself doesn't do any scanning, right? It is just merely a tool, an application where you have all your knowledge in. The knowledge about code examples, the knowledge about knowledge base items, the checklist, and the expert system that I showed you how to get the right security requirements. It is not scanning code or doing anything, right? So basically, how you would use it, you use the expert system in SKF, right? So you use it before you develop. You say, hey, I'm going to build a search functionality. So you get these requirements. Then when you're developed, you implement these things, these advices over here, right, in your search functionality. Then afterwards, what you can do is also give the pen tester, the security engineer, these requirements and say, hey, I implemented all these things because they were needed from a security point of view. Can you validate this as well, right? So then you have the security by design, the awareness, implement all the requirements as a developer, and then you could also tell the security specialist, the pen tester, like, hey, these are the requirements that I used, the functional and the security requirements. Please verify that they were implemented correctly. But again, that's why we also have the labs. So I would advise as a developer also to do these type of hacks and injections and security awareness, because with this knowledge you can also verify, you know, a lot of those requirements yourself. So it's not only the pen tester who can find it, but you as a developer also have the right knowledge then to verify and start verifying your application and your functionality that you're building.
Okay, thank you for that. Someone also asked if there's a way to integrate this on Docker.
Yes, for sure. So let me also paste the whole link, you know, the repository of SKF in the chat. So here you can find the project, and basically we have a couple of things. We have the Kubernetes installation, we have the Docker Compose. Well, and I'm also running it on a Raspberry Pi, and you can install it bare metal, but mostly people use it Kubernetes. So big organizations, they deploy it using Kubernetes, and developers who want to use it like locally or like, you know, they can use Docker Compose. So basically what you can do, git clone, make sure you have Docker Desktop, enable Kubernetes in Docker Desktop, and then it's basically Docker Compose up and go to localhost, and you have everything there. To the same stuff I showed you over here will then be locally running, yeah, on your machine. So the whole SKF will run locally, or like I said, you can also deploy it in using Kubernetes. How to set it up, which variables to set with what information. Here I have an example how to deploy it on the Google Kubernetes environment. Yeah, and then you have everything running in the cloud.
Okay. The last question for today. Someone says, I see sample of the juice shop and those OWASP samples implemented in the lab. How do we import our own project to test using the lab features?
Yeah, it's actually not that hard. What you need to do is you need to add your new labs in the database, and you need to push your image of the lab that you have built to your Docker Hub repository.
Okay. Okay.
So,
Okay.
but let's say if you have indeed your own project and you say like, wow, I also want my project to be here so other people can use my project to and my lab to teach and learn, just give me a message and I will make sure that it will be available in here.
Okay. 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 So, and he has provided a Slack channel where you can actually reach out to him. Yeah.
Yeah,
So,
I just posted
yeah.
it, so it's in the chat. Let me see. Yeah, a couple of lines above. It's in there. So Slack or Gitter, and I pasted the GitHub repository of SKF as well.
Okay, it's been a quality 1 hour 5 minutes you spent with us. We sincerely appreciate you, and we do hope that some other time when we call you, you would be willing to spend some more time with us. I sincerely appreciate the quality 1 hour, and I hope others have also learned a couple of things from what you have actually shown us today. And I'm sure we're going to take it up from there, and we'll reach out to you on the Slack channel. And I'm sure we don't have any other question for now. If there are any other questions, they will definitely get back to you through the Slack channel.
Yep.
I'm connected with you on LinkedIn already. I'll definitely pause you. Thank you very much, Glenn, for coming.
Yep.
We do hope to have